Dead men tell no tales, but their ships speak volumes. Welcome to the Cursed Compass, where we explore the darkest maritime mysteries. In 2024, explorers Daryl and Dan Early were scanning the waters off Michigan's Upper Peninsula when their side-scan sonar hit a small blip. They had located the wreck of the Western Reserve, a ship lost 132 years ago. The sonar revealed a specific physical state. The 300-foot freighter had snapped in two. This 150-foot aft section came to rest directly on top of the bow, indicating a precise structural failure at the midsection. Built in 1890 and owned by inventor Peter H. Minch, the Western Reserve was the first steel-plated freighter to operate on the Great Lakes. Its speed earned it the nickname the Inland Greyhound. When it vanished on August 30, 1892, it left behind a century of questions and a single survivor. The physical evidence suggests the loss was the result of early steel metallurgy meeting the unique hydrodynamic stresses of these inland seas. By examining the alignment of these two hull sections, we can reverse engineer the mechanical forces that forced the steel to its breaking point. The ship's final voyage began in calm waters. Carrying the Minch family and a crew of 22, it set off across Lake Huron toward Two Harbors, Minnesota. As the ship entered Lake Superior, it encountered a late summer storm. These systems are driven by the temperature differential between warm surface waters and descending cold Canadian air. Because fresh water is less dense than salt water, it reacts differently to high-velocity winds, creating a specific type of wave dynamic. Freshwater storms produce steep, high-frequency waves. These crests strike a ship's hull in rapid succession, creating a tight, punishing cycle of impact. For a long freighter, these rapid waves create an uneven distribution of buoyancy, turning the lake into a structural hazard for a 300-foot hull. To understand the resulting damage, we have to look at longitudinal bending moments, the forces acting along the entire length of the ship. This illustrates a condition called hogging. When a wave's peak positions directly under the midship, the vessel's center is lifted. The bow and stern hang unsupported over wave troughs. Their immense weight forces excessive downward force, turning the midsection into a fulcrum. This downward force is increased further if the ship's internal ballast is insufficient or improperly distributed. On the night the Western Reserve was lost, the wavelength of the storm matched the ship's dimensions, maximizing this bending moment with every passing wave. In 1892, shipbuilding was transitioning from iron to early Bessemer and open-heart steel. These materials were favored for their strength, but the industry was still in infancy. Quality control in 1890 steel production was inconsistent, often allowing carbon impurities to remain in the final plates. These impurities created patches of brittle steel within the hull. Unlike modern flexible steel, these rigid plates lacked the elasticity to survive rapid cycle hogging. Once bending stress exceeded the material's limit, a single microcrack formed, propagating instantly across the hull's entire width. This sudden failure explains why the ship sank in just 10 minutes. The only survivor, Harry Stewart, managed to swim to shore, but the rest of the crew and the Minch family were lost. The theory of a metallurgical flaw is supported by the loss of the W.H. Gilcher, a sister ship built at the same time using identical runs of steel plate. 8 weeks after the first tragedy, the Gilcher vanished in a Lake Michigan storm while carrying 3,000 tons of coal. There were no survivors. The only recovered debris consisted of shattered pieces of the pilot house and bridge floating near the Manitou Islands. The identical material profiles and matching circumstances of these losses point to a systemic structural vulnerability in the ship's design. Because these sinkings were so rapid, they generated myths of ghost ships and supernatural disappearances, like the legend of the Erie Board of Trade. Stories of crews vanishing into strange clouds likely stem from reports of the Gilcher entering thick fog shortly before its sudden, violent structural failure. The 2024 sonar scan reveals the physical signature of this failure. The overlapping hull sections match the mechanical profile of a ship that snapped under longitudinal stress. With up to 10,000 wrecks on the lake beds, the Great Lakes remain a significant proving ground for naval architecture. These same forces were present in the 1975 loss of the 729-foot SS Edmund Fitzgerald. Like the early steel freighters, it suffered a sudden demise without time to send a distress call. The trailing ship, the Arthur M. Anderson, witnessed the Fitzgerald vanish from radar in seconds, a modern echo of the rapid disappearances seen in 1892. The hydrodynamics of these inland seas forced a reevaluation of how ships are built. The tragedies of 1892 eventually led to the development of the rigorous metallurgical standards and stress models used in modern ship construction.